Okay, finally we have a question like this. This is actually an O-level question, and it's actually a fairly common type of O-level question. Okay, so instead of asking you to draw a scale diagram from scratch or giving you a diagram to scale, they will give you some lines, ask you to complete this diagram, but using your own suitable scale. So if you see the word suitable scale, that means you are coming up with your own scale. Okay, but they also ask you to use the lines below. So you're going to use these lines using your own suitable scale to come up with a diagram. Okay, meaning you don't take this odd scale and you try to do some like math with it. You're supposed to choose your own scale yourself. Okay, so a girl has a weight of 400 newtons, so there's a weight, and then this is showing the girl being pulled by the ropes, right? The force in each rope is 500 newtons, which means this is 500 newtons, this is also 500 newtons. So this force is going to be 500 newtons, this force is going to be 500 newtons. Okay, and the angle is 60 degrees, so they've done that already to scale, so this is fine, right? So you need to complete this diagram. On your diagram, you need to remember to show the direction of each force. Okay, so first you need to determine a suitable scale. 500 newtons, look at the space. So you want to choose a good scale. A good scale is an easy to read scale. 500 newtons, you look at the space, you have maximum about 7 cm to work with. You could make it 10, but then you're going to be drawing all over the lines, you don't want that, all over the words, you don't want that. So the most reasonable length to use is 5 cm to represent 500 newtons. So I'm going to write the scale here. The scale, if it's 5 cm, represent 500 newtons. Then 1 cm represents how many newtons? 100 newtons. Right? So actually, this is your final scale. This is your working step. This is your final scale. 1 cm represents 100 newtons. Okay? After you've drawn your scale, you need to complete the diagram. What you're going to do is you are going to show where your force ends. Okay? So I'm going to measure 5 cm because this force is 500 at each, right? I'm going to measure 5 cm from here. Measure 5 cm. And then I'm going to mark that and show that, okay, this is where it ends, right? So I'm going to draw the arrow here and say that, okay, this is where it ends. I'm going to do the same thing for this side. Measure 5 cm. And then say, alright, this is where it ends. Okay? Then I'm going to complete the diagram using the parallelogram method. So let's start with this one. I'm going to draw a parallel line. Okay, obviously, again, know that your resultant force will be upwards, right? So, okay, remember to label your forces. So your force will be, this one will be 500 newtons, 500 newtons. Okay, so you already can guess that your resultant force can be straight upwards in the middle. Okay, so again, align your sail vertically, put in the boat, hold the boat steady, slide the sail. Okay, until the tip of the next force. Then hold the sail steady, draw a dotted line. Okay, next, I'm gonna draw for this force. So you align the sail vertically, put in the boat, hold the boat steady, flush the boat with the sail, hold the boat steady, slide the sail to the tip of the next force. Okay, remember to make sure that it is still flushed at this point, flush with the boat. Okay, so again, it should be a dotted line, but I'm just gonna do the heck to make it easier. Okay, so of course the resultant force is again from the origin to the opposite corner of the parallelogram. So from the origin to the opposite corner of the parallelogram, Just draw a line across. Remember to put in the arrows. Of course, it's upwards, right? So calculate the resultant upward force on the girl. To calculate it, you just measure the length, 8.5. So you can just write 8.5 cm. So if 1 cm represents 100 newtons, then 8.5 cm will represent 850 newtons, and that is your final answer. Okay, so actually fairly simple once you've got the basics down. Alright, just make sure you get a good scale and choose the good scale yourself. Okay.